there, everyone. Welcome to episode number 605 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. How about we send some stuff to space? I am super happy to welcome Mike Johnson, co-founder and CTO of SEOPS, to Fish Fry this week. Mike and I chat about the motivation behind the creation of this innovative aerospace company. We explore the history of space solutions for national security, scientific, and educational endeavors that SEOPS has been a part of. And we also investigate the different services they offer, including end-to-end mission integration, LEO and Lunar Rideshare services, tailored mission design, and consultation services. So let's go to space, my friends. Please welcome Mike to Fish Fry. Hi, Mike. Thank you so much for joining me.
Hi, thank you, Amelia. My pleasure.
Excellent. Okay, so first off, tell my audience about SEOPS and the motivation behind its creation.
Sure. Well, I like to explain to people in the simplest terms. At SEOPS, we fly your stuff in space. So we launch satellites into space using various launch vehicles. At the moment, we are almost exclusively on the SpaceX Falcon 9 transporter missions, but we've used other vehicles in the past, and we'll talk about that a little bit later. The motivation behind the creation of SEOPS was strictly to launch satellites into space. My past experience and my partner, Chad Brinkley, we saw the need on the horizon. We were involved in the early days of small sat launches into space. And we're like, we need to set up a company that just focuses on getting things as fast and as cheaply as possible into space. So that was our motivation.
I love it. Now, you guys have quite a history of rideshare launches, ISS rendezvous, and small sat deployments. So give us a rundown of your successes.
When we started in late 17, early 18 timeframe, rideshare on normal rockets wasn't the most popular. In fact, most people were going over to India to fly on the PSLV. My prior experience, I was a co-founder of Nanoracks, and prior to that, I flew commercial payloads on the Space Hab program. And what I learned was that the secret to rideshare is basically flying in the cracks. Typically on various missions, there are places to fly satellites, small satellites in particular, sometimes large satellites, in combination with the primary payload or payloads that are flying on the whatever respective vehicle you're going on. This kind of mentality started with me back in the early 90s while I was at Space Hab, and we were flying just a variety of small internal payloads inside the pressurized volume in our module that was in the payload bay of the space shuttle. And in the 90s, that was almost unheard of. People were like, oh my gosh, we can fly something in space in microgravity, astronauts will tend to it, and we can actually do science on orbit. For me, it was odd because I was trained in a mentality of, rideshare is not a problem. You can do this. It's possible. And as time went on, I started seeing in the launch vehicle industry, for example, like trying to fly on an Atlas rocket. Oh my God, this is impossible. And there were a lot of people telling me and my peers that this was not possible. And I was like, that's kind of crazy because I just got out of totally possible at Space Hab. And then in 2009, I was co-founder of Nanoracks, and we started flying things internally on the space station. But eventually it transformed into flying or deploying CubeSats off the International Space Station, and then later the larger satellites, and then eventually, Nanoracks placing its own commercial airlock on the International Space Station. And at the end of 17, my partner and I, Chad Brinkley, we started seeing that really a lot of future, a lot of opportunity in flying small satellites on just regular launch vehicles and also on the space station. We broke away from Nanoracks and started SEOPS, focusing just on flying satellites to orbit on rideshare. So we started off with our slingshot system, which we would fly prepackaged deployers, prepackaged with CubeSats and a little bit of extra hardware that would fly up to the International Space Station on cargo vehicles such as the Northrop Grumman, then Orbital Sciences Cygnus, or the SpaceX Dragon capsule. And they'd fly up in these soft bags. They're fabric bags, kind of like, ballistic luggage, if you will. These things would fly to the International Space Station. The crew would transport them from the cargo vehicles over to the space station side. They would mount the deployers with some special hardware in the hatchway of the Cygnus cargo spacecraft just before it departed. Typically, what they would do with the Cygnus is they load up trash into the Cygnus cargo vehicle before it departs from the space station. They close the hatch. Then they would mount our deployers with satellites on the hatchway. And then shortly thereafter, the Cygnus would depart from the space station, go to higher altitude, and deploy satellites. Sometimes we would fly hosted payloads, which were able to test out certain things like antennas or other types of equipment, but it would remain on or attached to the Cygnus, and we'd use the Cygnus communication system to transmit information to the ground. So we had about 5 flights of the Slingshot, and then around 2019, SpaceX announced that they were going to start flying these transporter missions, and we got very excited about that. In fact, I'd been waiting for quite a while for SpaceX to come around to flying rideshare missions. It took quite a while for that to happen. I think SpaceX tried to do it on some of their early flights to the International Space Station, the early Dragon flights to the International Space Station, but it just wasn't the right time, a little too early, I think. But in 19, they announced the transporter missions, and we were right at the front of the line to get onto these missions. And we flew our first transporter mission on Transporter 5. We started flying our specialized equalizer deployers, which are CubeSat deployers, on the SpaceX transporter missions, and we've been going strong ever since. We're approaching about 60 satellites now within the SEOPS Corporation, and in my past history, there's, I think, around a total of about 430 total satellite deployments from my past work at Nanoracks and the SEOPS work. So, and then we've also flown some internal payloads on the International Space Station, a little bit of work there. So all in all, we've had quite a run, and things continue to just grow. In particular, we're very excited about the future with SpaceX, in particular, the Starship missions. We are on the edge of our seat waiting for the Starship missions to begin, because at that point, we're starting to talk about, 100 metric tons to orbit in one launch. This will be an incredible situation. And honestly, I think people in the aerospace industry are really not prepared for this event horizon. I mean, it's coming up quickly, and it's going to be amazing, because all of a sudden, you'll be able to fly your F-150 truck in space. You could actually afford it. I'm thinking the pricing will go down. It's going to be a paradigm shifter. People aren't ready for this yet. We're not ready, but we're getting ready.
I love it. SEOPS also offers integration services, rideshare to LEO and Lunar, and tailored mission design and consultation services. Mike, can you tell me a bit about each of these solutions?
Sure. So beginning with the integration services, what we do is we help our customers get on the rocket. To get your satellite onto a rocket, depending on what kind of satellite it is, requires a few different things. In particular, there's pre-flight testing that we have to do, vibration testing, static load testing, some electronic and thermal testing, possibly. We guide the customers through that, because a lot of times satellite builders will come to us and they're very focused on the satellite. And I wouldn't say they've lost track of the fact that they have to go on a launch vehicle, but the launch vehicle, from a satellite builder's perspective, is a kind of a secondary thing. And of course, the different launch vehicles may have different requirements. So we help people get through those wickets as quickly and inexpensively as possible. A lot of times we will also help with radio licensing. This is another very big area that satellite builders may be unfamiliar with, radio licensing and the regulations surrounding that. And in particular, the FCC has inherited a strange job. They're basically the gatekeepers for controlling space debris. They've ended up, controlling and monitoring the reentry capability and reentry status of various satellites. And it's kind of a weird thing, when you have government agencies, sometimes they inherit some strange jobs. And that's what's happened with the radio situation. The assumption is that all satellites require radios. So if you're going to control the demise and disposal of a satellite, you don't want a bunch of space junk flying around. What better agency than the Federal Communications Commission? It's a bit of a strange bedfellow situation, but we help with that. So our second solution here, rideshare to low Earth orbit, LEO. This has been our primary focus in the company since its inception. And what we will do here is various launch vehicles. We broker and manifest your satellite onto the correct launch vehicle or an available launch vehicle, depending on the situation. Of course, we shoot for the lowest cost in whatever situation we're in. We do get some interesting situations where people want specific orbits. Maybe they want a certain orbit altitude or a certain orbit inclination. We try our best to accommodate these situations. Sometimes, unfortunately, as a ride share, you're a small payload. So if you have a unique orbit compared to other launch situations, we try our best to basically find you the right launch vehicle and launch time. I would say this, though, the launch vehicles are not as much of a commodity as people think they are right now. Launches are still not super regular. And even though SpaceX is launching in some cases up to 3 times a week, what we have to remember is that most of those launches are for the Starlink missions to launch and deploy the Starlink satellites. And typically they don't do a lot of rideshare on those missions. We do find and broker and arbitrage too various launches. Of course, launches are still rather expensive, and it's important that from our perspective, we are able to provide, say, multiple launch opportunities for various customers. And in order to do this, we have to basically arbitrage over many different flights. And this can be rather expensive, and it's almost impossible for a single satellite builder, unless they have a very large constellation or flying quite frequently. It's really difficult for these providers to go out and find various locations on these various launch vehicles. But this is an advantage that we have at SEOPS because we have so many customers coming in. We have a large base, kind of a standing army of launch vehicle opportunities, and we broker these for the various customers. And then another exciting thing, the third area you asked about was lunar and tailored mission design. Just a few years ago, if someone would have told me that it's possible to go to the moon or the lunar vicinity as a small commercial satellite, that opportunity existed, I would have fallen off my chair. It's quite amazing that here just recently, and it's really just the last couple of years, this has opened up. We have the ability to go to the moon. And once again, I give a lot of credit to SpaceX for being able to do this. It's amazing what's happening. And at SEOPS, we provide potentially lunar lander and lunar vicinity opportunities through various providers that we've partnered with. Believe it or not, you could actually send stuff to the moon today. It's possible. Also, as I mentioned before, we have our tailored mission design and consultation services. If you're kind of stuck in a situation, and you don't have to necessarily fly with us, but if you're stuck in a situation where you may have some radio problems or testing problems, things like that, we can provide services to satellite builders and others who may need these needs. We can satisfy these needs on a very quick basis. We're constantly testing, constantly working with licensing agencies, government agencies, and the launch vehicle providers. Another thing, too, it's very important. This world is changing so quickly, you have to keep up to date. You have to maintain your presence in the field. It's surprising how quickly some concepts and methods can become obsolete, but we're learning a lot as we go here.
Absolutely. So, you guys recently partnered with Intuitive Machines to provide new lunar rideshare services as well. So, tell me about that collaboration.
Yes, well, this is very exciting. As I said, just a couple of years ago, this would have been impossible. But Intuitive Machines, as you know, they recently put a lander on the moon. Amazing situation. They have purchased a few launch vehicles from SpaceX to launch their vehicles either to the vicinity of the moon or land on the moon. Through our partnership, they've offered us rideshare opportunities where we can bring in smaller payloads, say, and rideshare on these lunar missions. I say smaller payloads. If I'm not mistaken, we can fly up to about 400 kilos. So these are relatively large payloads. It's just opened up a whole new world of opportunity, in particular in the cislunar environment, too. A lot of people are very interested. DoD, commercial entities, are very interested in putting satellites into the cislunar area. So the area between the moon and the Earth or behind the moon, it can open up a wide variety of communication relays, Earth observation, lunar observation situations. There's some astronomical situations on the backside of the moon where the moon acts as a radio shield. There's also some communication satellite situations that in the lunar vicinity, these communication satellites can reach certain places on the Earth that are typically not accessible by other communication systems. So there's a lot of opportunity, and we're very excited to get creative in partnership with Intuitive Machines to exploit these situations. It's going to be really fun.
That's fantastic. Now, SEOPS also offers a variety of hardware solutions as well. So, talk to me about those.
Yes, well, this is kind of my area in particular, my sweet spot. As I said earlier, we've designed specialized deployers. It started with the slingshot system. We had to fit some deployers in a very tight, oddly shaped area. This is a hatchway on the front of the Cygnus. For example, that volume is about 2 meters in diameter. Well, that's great, but it's only about 250 millimeters deep. Well, I wasn't able to put a normal CubeSat deployer in a normal orientation where the CubeSat would deploy along its long axis. So we had to design and create, and we actually got a patent on it, a different type of deployer that deploys the CubeSats sideways. That was a kind of a strange situation, but we took advantage of it. And we later found out that that particular deployer also, because it keeps the center of gravity of the satellite very low and close to the launch vehicle interface between the deployer and the launch vehicle, that it provides a very soft ride. Typically what happens with satellite deployers or even satellites, their payloads are extended out quite a ways from the interface plane between the satellite and the rocket. And it causes this kind of, if you can imagine like a diving board or a tuning fork is wavering around in the breeze because everything is just attached down at the base next to the rocket. Well, with the slingshot deployer, which we renamed Ghost Trap because it looks like the Ghost Trap on Ghostbusters, the movie, the Ghost Trap deployers provide a very soft ride without the use of any special isolation equipment. So we're kind of excited about that. And of course, we have our standard equalizer deployers. These are CubeSat deployers. They come in the rail and tab formats. That answers a lot of the mail on a lot of deployer requirements. Sometimes deployers are kind of hard to get these days. They have long lead times. And we try to keep our prices as low as possible. So hopefully everybody gets a very good deal on our equalizer line. And we're also working on a new line for a separation mechanism for microsatellites, say satellites in the, I would say, 25 kilos up to 700 kilo class satellites where we have separation mechanisms that provide very rigid attachment between the satellite and launch vehicle, a lower cost, and our goal, because we've been working on this for quite a while, and making sure that we can mass produce these separation systems, we should have very short lead time and very good availability of these, what we call the keystone separation system equipment. So these are our primary hardware solutions. We have a few other things for hosted payloads that are available, but primarily, like I said, we're focusing on deploying satellites. So we have CubeSats, which deploy primarily off our equalizer deployers. And then we have the microsats, which will be deploying off the Keystone separation mechanism. And in the future, on Starship, we also have a separation system we call Monkey Wrench. We just issued a patent on this recently. And the Monkey Wrench system is for very large satellites. And we're looking at flying hundreds of kilos to in the thousands of kilos on the Starship system. And this is going to require some brutal separation mechanisms. And with the Monkey Wrench system, it's unique in that it utilizes basically a nut and bolt connection. And the patented aspect of it is removing the nut and bolt while you're on orbit to separate the large satellite or the large load from the launch vehicle. So we're excited about that too, but we're thinking that one is probably a little more adaptable to the Starship situation as things start getting much larger in the future.
That is exciting. All right, Mike, it is time for your off-the-cuff question. So if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
Steak tartare.
Nice.
I was in Poland about a month ago, and I ordered as much steak tartare as I could. I don't know why, but I can't find it very easily in the States. I'm probably looking in the wrong spot, but I was in heaven, and I just love tartare.
I love it. That sounds delicious. Well, Mike, I think that's all I have time for today. Thank you so much for joining me.
Well, thank you. It's been my pleasure. And like I say, for your audience, if they need anything in this area, if they need to get a satellite to space, just give us a holler, and we'd be glad to help you.
And if you would like any further information about SEOPS, I've included a couple links below the player on this week's fish frying page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into X, you can monitor our tweets at EEJournalTFM. And don't forget, if you would like to follow my personal account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn as well. And we are also on Blue Sky Social and Mastodon too. And you guys, we have a YouTube channel, youtube.com/EEJournal. It is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and our brand new animated series called Libby's Lab. And of course, you can subscribe to our EE Journal YouTube channel as well. Also, make sure that you subscribe to this here podcast on Spotify, Podbean, Apple Podcasts, YouTube, or just about any other podcasting platform to listen to some exciting upcoming episodes. Thank you, everyone, for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of October 25th, 2024, I'm Amelia Dalton, and you've been fried.